Okay, let's do practice problem number 2 on page 476. And here's the problem right here. Let's zoom in on the book. So there's number 2. And it says a negative charge of negative 6 times 10 to the negative 6 coulombs exerts an attractive force of 65 newtons on a second charge that's 0.050 meters away. What is the magnitude of the second charge? Okay, so here's what we've got. We've got a charge. Well, actually, it's negative. Let's make it negative. Got a negative. Oops. Zoom out. You guys help me out here when I'm recording. And so here's Q1, and we know what the distance R is, and here's Q2. I don't know whether it's positive or negative. Does it say? It's an attractive force. Okay, so that was given too. And so we know that that electric force is equal to K Q1 Q2 over R squared. Now it says it's an attractive force, so since this is given to be negative, if it's attractive, what does Q2 have to be? It has to be a positive charge. So we got that. So now we can just take this expression and solve it for Q2. And so this is in the negative R hat direction. So I'm just going to solve for Q2. So this is going to be the electric force, which was given, times R squared, that's given, divided by K, which we know, and divided by Q1, which is given, and divided by negative R hat, or divided by negative 1, basically. Remember, R hat is just a way of saying it's attractive. So it doesn't add any value, it doesn't change anything. So this is going to be 65 newtons, and R is 0.050 meters. So we're going to square that. We're going to divide it by 9 times 10 to the 9 Newton meters squared per coulomb squared. And then Q1 is given to be negative 6 times 10 to the negative 6 coulombs. Now this negative 1, I'll just put a negative 1 there. We already know that we have to cancel out this negative. We already know that Q2 is positive because it's given that it's an attractive force, and it's given that this is negative, so this has to be positive. But if you want to be rigorous about it, you keep that negative in there. It cancels with the negative there, and it gives us a positive charge. So Q2, let's see, 65, let's do the math. 65 newtons times 0.050 squared equals, and then I'm going to divide that by 9 times 10 to the 9 equals, and I get a small number. But now I'm going to divide by a really small number. Now I could just cancel out that negative sign there, so I'm not going to plug that into my calculator. So I'm going to divide by 6 times 10 to the negative 6 equals, and I get 3.01, I guess. We could round it off to just 3. Times 10 to the negative 6 coulombs. Well, I'm going to cheat and say that's microcoulombs. And it's positive. It is a positive charge because it's given that the force is attractive. Now I'm going to check my answer. Where is my answer? This is number 2. Yep, 3 times 10 to the negative 6 coulombs. Boom. I checked my work. I put a star next to it. Even I put stars next to things that I got right. Okay, any questions on practice problem number 2? Okay, well, then that is...
Oh.
That was better.